When the bleep are we going to use that?
Before we learn about two-step equations, we need to go back to the basics and talk about the order of operations. PEMDAS is how we represent the order of operations. It stands for parentheses, exponents, multiplication, division, and addition, subtraction. It teaches us the order that all operations have to happen. If this order is not followed, you'll never evaluate any answer correctly. Now, it's important because order of operations dictates everything we do with equations. So we start with parentheses. We're going to take care of anything that's in any type of grouping symbol. So parentheses, brackets, those little squiggly brackets that probably have a name I'm too lazy to look up. Then we look at our exponents. After all the values inside of parentheses, remember, within parentheses, you have to follow the order of operations. We move on to our exponents. So any exponent, that includes square roots. Multiplication and division are lumped together. Because we don't do multiplication then division, we do them from left to right. They're together because they're inverse operations. Multiplication undoes division, division undoes multiplication. They're inverses, opposites. Addition and subtraction are lumped together the same way. They are inverse operations. Addition undoes subtraction, subtraction undoes addition. They go from left to right. So you don't do addition then subtraction. You look at what you have and you go from left to right. You could do subtraction then addition. If you follow every step, every operation in the correct order, you'll evaluate the correct values. On your own, try a little think, pair, share. Evaluate the problem, answer the questions. Pair up with someone, a student, a parent, a teacher, and describe and discuss your findings. Then in class, we'll share what you find. Two-step equations may seem overwhelming, but we can break it down into 6 easy steps. The first, just like with all equations, we ask ourselves, what's happening to the variable? Now, it's kind of a bigger question. We don't just have one operation. We need to list both operations in order. In order means order of operations. So if I look at the equation in the right-hand corner, the variable's on the left side, so the left expression, I'm just going to look there. I see 3x minus 5. 3 next to an x is multiplication. Remember, you put two rabbits next to each other, they multiply. You put a value and a variable next to each other, they multiply. So I see 3 times x minus 5, multiplication and division. If I were to follow through the order of operations, there's no parentheses, there's no exponents. I would do multiplication first. I'm multiplying by 3. Then I would take care of my addition subtraction. So I would minus 5. This is what's happening. This question is often overlooked, and it makes the next question very hard to answer. Step 2, ask, how do I undo the operations? Well, I know what my operations are. I even know the order they're presented. I need to write the inverse operations for each of the current operations. Well, the inverse of minus 5 is plus 5. The inverse of times 3, or multiplication, is dividing by 3. I have an order now. Before, I multiplied 3 and subtracted 5. That's what was happening. Solving an equation is about going backwards and undoing that. So I'm going to add 5 and then divide by 3. Notice the arrows are switched. Those arrows help you not only organize the values, figure out your inverse operations, but it tells you which operation to do first, which operation to do second. At this point, it's very straightforward. I'm going to apply the first inverse operation to both sides of the equation. This is just like what we did when we solved one-step equations. So if I add 5 to both sides, minus or negative 5 minus 5, however you want to look at it, plus 5 gives me 0, which is my identity for addition subtraction. So I know I've canceled out that value. I'm going to add 5 to the other side. Equations have to stay balanced. 7 plus 5 is 12. So I'm going to evaluate each side of the equation, giving me 3x equals 12. I'm going to do the same thing again, but I'm going to apply the second inverse operation to both sides of the equation. Again, I need to do it on both sides to keep things balanced. Well, I added 5. If I follow my arrow down, I'm going to divide by 3 next. 3x divided by 3. Well, 3 divided by 3 is 1. That's my identity. So I'm evaluating each side of the equation. If I divide 12 divided by 3, I end up with 4. X equals 4. Always circle your answer. Your work is important, but make it easy for your grader to find your answer. Let's apply these steps again to another problem. Always ask what's happening to the variable. I need to list my operations in order. What's currently happening and how those values are affecting the variable. So I'm going to look at the left side because that's where my variable is right now. In order, I would have, there's no parentheses, no exponents. I see divisions, that'd be multiplication or division. So divisions first. I'm dividing by 5. Then I see subtraction, even though that could be read as -5, that's the same idea as -5. So that's the next operation that's happening. I need to undo it. I need to go the opposite direction. The inverse of dividing by 5, the inverse of -5 is +5. The inverse of dividing by 5 is multiplying by 5. I have my inverse operations, including the value. The value is very important. You can't just put plus and times. You have to put +5 times 5. I have them in order as well. So now I just need to apply them. I'm going to start at the top of that arrow. I'm going to add 5 to both sides and evaluate. -5 plus 5 is 0, which is my identity. I canceled it out. 2 plus 5 is 7. X over 5 equals 7. Now I just multiply both sides by 5. When I do that, the division and multiplication cancel out, giving me just X. 7 times 5 is 35. Always circle your answer. There we go. Step by step. You ask what's happening to the variable, you list it out. You ask how do I undo it, you list the inverse operations. That gives you the correct operations, the correct values, and the correct order. It's like creating a map of how to get from the equation to the solution.
Solve a two-step equation for democracy. Like climbing a ladder, Mr. G patriotically answers the question, what is happening to the variable, by listing the current operations. As he safely comes down the ladder, he lists out the inverse operations. Great job, Mr. G. Sometimes Mr. G has unpure communist thoughts and chooses not to use his inverse operations in the right order. Uh-oh, Fido, better call the paramedics. Mr. G applies the first inverse operation to both sides, keeping the equation perfectly balanced. After evaluating both sides, canceling out any identities, he rewrites the equation and repeats with the second inverse operation. His hard work is rewarded with a shiny new solution. But sometimes Mr. G leaks government secrets to the communist scum. Which is almost as bad as not keeping your equation balanced.
On your own, give these two problems a try. Remember, if you're not quite sure, rewind and review. Go back, look at my steps, look at my model, and apply what you've just learned to these new problems. Answers are available, but the work, the methods, the step-by-step process is the real goal. That's what you need to learn. That's what we need to see.